Hey guys, I've got all my gear set up. Here's my 4.5 volt bias pack on the AGC bus. I don't know if battery maker would approve, but hey, it does the job. There's a little RC network going to the VTVM. I've got my signal generator feeding in the 21.25 megahertz signal to the shield on the 6J62. And here's the reading on the VTVM. Now I'm supposed to adjust A1 for a minimum. A1 is this coil here, and I'm going to be adjusting A2, A3, A4, and A5, and those are just the sound. Like I was saying, I don't want to mess with the tuner by any means because that seems to be working fine, nor these video coils here. Just A1 and then the ones up here for the audio. So here's what I'm going to use. It's an alignment tool. It's got a metal slot in either end. Depending on what kind of coil you need to adjust, you use one end or the other. And use plastic so it insulates your hand effect from the actual coil. The coils themselves are these threaded brass poles that stick up here. At the other end of these threaded shafts is a piece of iron. Probably compressed powdered iron, a ferrite core. So what you do is you take this tool, this is the A1 coil here, and turn it around so that the slot on the end matches the slot on the end of this threaded shaft here, and you simply rotate. Now, I'm supposed to rotate this for a minimum meter deflection. So you see that I rotate this, is it dropping? It's starting to rise, so hey, I think that's pretty damn cool that it actually works like the directions indicate. And also means that the fact that I was able to rotate this about 2 complete turns means that this was way off from where it was supposed to be, which is kind of what I was hoping to see. Just a rise right in there, so right about there is a sweet spot. They say to decrease the output of the generator as you get close to the sweet spot so you can really hone in on it. And the reason you need to do this is that the sound and the video are actually come together on the TV channel. And for this type of set, they're both amplified together for a while until you get to this coil, and this coil picks off the audio signal from the video signal, throws it by 4.5 megahertz, I believe. And then once you're past this point, it pretty much is like a conventional FM radio. So I think thereabouts is the minimum. Alright, now I gotta make some more changes here. So I'm gonna put down the camera and continue on with this and pick up a little bit later in the process. I've been going through the instructions and I think I've been doing it right because things have more or less been going along with these, with what they indicate. Well, you know what's most confusing though was the very first step. They say to adjust the coil for a minimum. Well, I'm getting a negative value, so I don't know if they mean to make it the most negative or what, because these other settings, when I adjusted A2, 3, and 4, they were positive, and it was easy enough to adjust it so I got a maximum peak. But at any rate, I've moved on, and I'm at the point now where I'm checking the response curve, which is what I've got up here. Now, it just so happens with the way the my scope works, the response curve is actually flip-flopped of what they show here. So keep that in mind. Now, the way this works is the left-hand side of this is a sweep generator. what that does is you set this dial up for pretty much the center frequency, so about 20 megahertz in this case, and then you set the sweep width. And what that'll do is that will be the equivalent of taking something like this and rotate the dial back and forth, back and forth, back and forth. And it actually does that at the same rate as a line frequency, so about 60 times a second. It sweeps back and forth on the frequency. This one is all electronic, but this older one I've got down here, well, not older, but about the same vintage, but another way of doing it. There's literally a motor in this guy that rotates a variable capacitor that does the equivalent of you taking your hand and doing this. So anyways, I've got this centered around 21 megahertz, and it's sweeping back and forth. And I'm using what they call a demodulator probe on my scope, which has a detector diode in it and a resistor and a capacitor, just like the detector in an AM radio. So that shows you the envelope of the RF response. This little blip down here is what they call a marker, and that's this side. So what this does is it takes this fixed frequency RF generator and it mixes it with the variable frequency generator, and this little blip here shows you where this is positioned. So if I rotate this dial, that blip, or actually they call it a pip, climbs up and down their response curve. So you can see that you're supposed to get a peak around 21.45 and a dip around 21.05. Now mine doesn't quite look like that because my dip isn't quite as pronounced as theirs, which is probably still a little bit more tweaking to do. But I've gone through this a few times, and I think it's close enough that I want to try actually seeing if I have any sound, and then I'll fine-tune it from there. Some of these coils I adjusted quite a bit, so I'm hoping that I've got things close enough that I actually get some sound out of it. So I'm going to put the camera down and remove the bias pack and so on, and see how I did. Well, unfortunately, that did not solve my problem. Still just a hum. So what I'm starting to think now is that maybe one of these coils is actually bad. I noticed there was a dent in this can, and that may be suspicious, but I did pop both these cans open last night, and the coils looked okay cosmetically, and I have measured them, and the resistance seems okay. I mean, they're not open or anything, but I guess there could be a shorted turn maybe. So I guess it's back to the drawing board on this one. That's all for tonight.